Okay, so let's start with a quick recap of the last part of vectors that we learned. So recap from session 2. So what we learned towards the end of session 2, which was very important, was sine theta, cos theta, and tan theta in terms of projections. So we saw that our definition of angle and cos theta and tan theta and all changes when we move on from trigonometry with relation to a right angle triangle to trigonometry with relation to projections of something which has been rotated by an angle theta with respect to the xy plane. So first of all, our definition of angle becomes something else. We are no longer concerned with angle in a right angle triangle. What we are now looking at is angle with respect to x-axis. So if you have a line on a rod which is at this kind of position, this is an example of a situation where theta is, you can see, in first quadrant. So it's in quadrant 1, and in terms of projections, we take a standard line, so its length is 1 unit. So the length of that line is a single unit in whatever system we have, whether it is meter, centimeter, whatever. And then what we do is we drop to projections, or we drop to perpendiculars. We still have a couple of people joining in. So we saw if you drop a perpendicular on the x-axis, then this line this shadow that it casts, that is called the x projection. And similarly, if you drop a perpendicular on the y-axis, this is what we call the y projection. Or you can also think of it like that: if this point at the end, it has coordinates x comma y, then x is the projection on the x-axis and y is the projection on the y-axis. So accordingly, our definition of sine, cos, tan changes. So now sine theta is defined as just y, because remember L is a unit length. So when we think of it like how to calculate this y, in terms of trigonometry, we have y is the perpendicular. So we have y by L should be equal to sine theta in that triangle. So what is the value of y? It should be L sine theta. But L is already a unit length. So what is the value of y? It is nothing but sine theta. Similarly, the value of cos theta becomes x. And the value of tan theta is just the ratio of y by x. So when your angle theta is in first quadrant, you can see that all three are positive. So for quadrant 1, sine, cos, and tan, they are all positive, because x is positive and y is positive. Because the x projection is a positive quantity, the y projection is a positive quantity. And some of the standard values, you know, for example, that sine 0 is 0, sine 30 is 1 by 2, which will be the same thing as cos 60. Similarly, sine 37, that is a new value we learned last time, that is 3 by 5, and that is the same thing as cos of 53. Similarly, sine 45 is equal to 1 by root 2, which is the same thing as cos 45. And similarly, sine 53 is a new value we learned last time, that is 4 by 5, which is the same thing as cos 37. And similarly, sine 60 is root 3 by 2, which is the same thing as cos 30. And similarly, sine 90 is unity, which is the same thing as cos 0. Okay. So these are some of the standard values, but the important thing is all the values of sine and cos are positive. So tan you can just calculate by ratio. Tan is ratio of sine and cos, and that you can see positive. So in the first quadrant, all three quantities become positive. Now when we move on to theta in the second quadrant, so when we move on to theta in quadrant 2, or in other words, theta is something in between greater than 90 degrees and less than equal to 180 degrees. Then first of all, visually the situation looks like this. With respect to my x-axis and my standard xy plane, a rod is rotated like this. So this angle, as you can see, with respect to the x-axis, this anti-clockwise angle, this theta has now come in this category, right? It's like this. And we are still dealing with the standard unit length rod. So this time when I drop a perpendicular on the x-axis, you can see that the x projection is a negative quantity because it's on the negative side of the origin. It's negative. Whereas the projection on the y-axis, that's still on the positive side. So that is why what happens here is in second quadrant, sine theta, which is the y coordinate, is a positive quantity. Cos theta, which by definition is the x coordinate, or the x projection, that has now become a negative quantity. And therefore tan theta, which is the ratio of y by x, becomes a negative quantity. And then using that simple relation, we have the formula which we develop. So if you like, you can go through the derivation of the formula again, but I'm just writing them for reference. Sin theta becomes positive of sine 180 degrees minus theta. So if theta is an obtuse angle, you can see 180 minus theta is this small angle over here. This angle, let's say this is alpha. So that alpha is equal to 180 minus theta. So alpha is an acute angle, whereas theta is an obtuse angle. So that becomes like this. Similarly, cos theta, it becomes negative of cos 180 minus theta. It becomes negative of cos of that smaller angle. This becomes positive of sine of that smaller angle. And that tan now we can just understand from the ratio. Tan is y by x, so it's sine by cos. So it becomes negative because it's plus by minus. So the ratio becomes negative. So it is minus of tan 180 minus theta. So that becomes minus tan. Okay. So this was the complete description. This was the important thing in last time's lecture. That how we take sine cos in the second quadrant. Okay. So I'm just leaving this for your reference for a moment. Then we'll do some values as examples. So for example, now suppose I have to calculate. So as an example, suppose I want to calculate tan of 150 degrees. How much this is? So I can see that 150 is greater than 90 and less than 180. So it's in second quadrant. So I'll use the formula of second quadrant. The formula of second quadrant is that tan of theta is minus of tan 180 minus theta. So here tan of 150 degrees will just simply become minus of tan 180 minus 150. So that is negative of tan 30 degrees. And since we are familiar with the value of tan 30, we just plug in the value. Okay. Now, yes, of course, the point is that you can always come across a situation where this is not familiar. For example, if I ask you, what is tan of 145 degrees? You'll see that that is minus of tan 55 degrees. Now, the thing is, what is tan 55? I don't know directly. So I look up the table. I look up the table or I look up in a calculator and I find it out. It will be some value, and I just put in. So that's fine, okay. But yeah, at this level for physics, problems that you have at exam level and all that, they will always be familiar angles. So you will just have to know those few values which I told you in the beginning. Okay. Those values from the table which I told you in the beginning, this one, this set, you just have to know these. Okay. Just these, if you remember, that is more than enough. And where those values come from, okay, it is no, it is 9. Acha, haan, this is 35. Correct. This should be 35. But the point is, even 35, I don't know. 35 is still okay because it's very close to 37. So you can get away with taking an approximate value like tan 37. But anyway, my point is that if it's some unknown angle, then you always have the option of looking at a table or calculator. Okay. Yeah, you'll have the notes of the important values. Don't worry so much. Okay, you will get these notes. Last time's notes somehow got corrupted. I could not transfer to you, but you will get the PDF version of these lecture notes. So don't worry, you will have all the values. Okay. Now the thing is, you might ask, so value आया कैसे है? So the value has actually come. It's a geometrical fact. Okay. How does the calculator know, or how do we know from the table that tan 30 is this much, or sine 37 is so much? You have to actually draw using very careful instrumentation. You have to draw a right angle triangle using that value, and then measure its sides and calculate the ratio of the sides. That is how. So if you were to experimentally calculate, for example, if you want to experimentally measure the value of sine 30, what you'll have to do is you'll have to construct the right angle triangle using very careful geometrical instruments so that this angle is 30 degrees. Then measure how much that perpendicular and hypotenuse ratio is. So that particular perpendicular and hypotenuse ratio you will see in the case of 30 degrees will come out to be very close to 0.5 or half. And if you repeat it over n number of experiments and do a statistical average, because every experiment will give you a little bit of error. That's always the problem. In anything that we do related to experiment, we don't always get exact values as expected. So we always do repetitions of the experiment and then average it out. Okay, so that is what we'll have to do in that case also. And that's how you can show that it's actually equal to half. But anyway, here we're not really interested in that part. What we're interested in right now is that if I know the value of an acute angle, like 30 degrees or 37 degrees or 45 degrees or etc., all these things, then how from that I can know the value for tan, cos or sine of any obtuse angle. So that becomes the problem. So let's just see another couple of examples. For example, I want to calculate cos of 127 degrees. So again, you can see that cos of 127, it's in second quadrant. So we just write from the formula, it is minus of cos 180 minus theta. So theta is 127. So that becomes minus of cos 53. Now we know that cos 53 is 3 by 5. That's a known fact. Okay. How we know that? Because if we draw a 3, 4, 5 triangle, if this angle is 53, we know that these sides are 4, 3 and 5. This is a known fact. Okay. So I use that value, that cos is this much. Okay. So this becomes minus of 3 by 5. Or you can write it as minus of 0.6 because 3 by 5 is the same. So cos 127 accordingly becomes minus of this. Okay. So that's how. Similarly, for example, if I wanted to find out sine of let's say 143 degrees. Okay. So this would become sine of 143 is, remember in second quadrant sine is positive, so it is positive of sine 180 minus 143. Okay. So that would come out to be sine 37 degrees. Okay. Now just like you have this triangle, if you invert this triangle, you will realize if you take this side as 3 and this side as 4, now you can see that this angle, यहाँ पे ये angle कितना था 37 था 90 minus 53, so that angle has now come here. Okay. So you know that sine 37 is actually 3 by 5. So this is 3 by 5. But importantly, positive or positive of 0.6. Okay. So that is how we use the values. Okay, now we'll extend this idea today to more than 3 quadrants. But first, just make sure you understand these 3 basic examples I've given you here. So I'm just going to minimize this a little bit for you. Okay, so the standard values you should remember are 0, 30, 37, 45, 53, 60, and 90. And I've given the values on top, you will get the notes to don't worry. Let's also make use of one where there is 19 volt. Okay, so hope this is clear. Okay. Now a quick example for all of you to solve. Yeah, there's nothing to understand, Shikhar, in the value. Is utna hota hai. Like you know, cos 30 degrees is root 3 by 2. Like that, you should know that cos 37 is simply 3 by 5. That's a factual thing. Okay. So there is nothing to understand in that. That's a factual matter. So now just try this out. Okay. So find sine of 180 degrees, cos of 180 degrees, and C tan of 135 degrees. Just calculate these values. Yeah, Shikhar, maybe you're not getting all my audio properly. Okay, I'm saying again and again, it's a factual thing. There is no how. तुम draw करोगे तो वैसा आएगा. If you draw a right angle triangle with sides 3, 4, and 5, you'll see those angles will come out to be 37 and 53. Or if you use a protractor and draw a triangle which has right angle triangle which has the other two angles as 37 and 53, you'll see that the sides ratio are like that. It's a factual matter. It's a geometrical fact. Yeah, so I'm getting some answers. Let me confirm. Okay. Yes, Durgesh, your answers are correct for sine and cos. Tanishk, your answers are correct. Ayush, you have to check the sign. No, Ayush, actually your answers are wrong. Tanishk, you have to check the sign. Tanishk, check the sign. Somarup, your first answer is correct. Durgesh, both your answers are correct. Somarup, your second answer is also correct. Durgesh, your second answer is correct. Somarup, your third answer is also correct. Tan 135. Kushal, correct. Rimjim, correct. Varin, correct. Atharva, you have to check your values. It's not correct. Yeah, Durgesh, the last one is correct. Aditya, correct. Ritika Singh, correct. Pradnesh, correct. Rimjim, your second answer is correct. Rimjim, your third answer is also correct. Rahil, correct. Atharva, correct. Okay, so most of Ananya, correct. Pradnesh, correct. Sushant, correct. Rahil, correct. Ritika, your third answer is also correct. Yujit, you have to check your answer. Okay. So let us, okay, so sine 180 will become positive of sine 180 minus 180. This formula we use. So it is positive of sine 0, but that is 0. You know that this is 0. Similarly, in the second part, you have cos of 180, which is minus cos of 180 minus theta. So theta here itself is 180. So that is minus cos 0. And cos 0 we know is unity. So this becomes minus 1. This is the value of the second one. And similarly, the third one, tan 135 will become minus tan 180 minus 135. So we just systematically work this out. There's nothing. It's it's like a manual kind of process. There is no thinking once you are familiar with the formula. So this is also minus 1. So these are the values. Correct. Priyanshu, correct? Okay. So if you just know how to calculate these sort of basic values, it's enough. There's nothing more that is required at this point. Okay. So just make a note of this, and next we will look at how to first we'll go a little bit ahead and understand the other two quadrants, quadrant 3 and 4. Then we will come back to your worksheet. So also make sure you have the worksheet 2 in front of you. We can refer to the questions. Okay, very good. Tanshu, you've been explained in the maths lecture. So then it'll be very easy. We'll do it very fast. But it's important we understand it from the vectors point of view also. So don't worry. I mean, thoda sa repeat hoga, it doesn't matter. Good. So let's quickly run through third and fourth quadrant. It won't take that much time because you've understood second quadrant. So next is theta in quadrant 3. Or theta is greater than 180 degrees but less than equal to 270 degrees. So for example, would have theta something like 240 degrees, or you would have theta something like 210 degrees. You would have theta something as 217 degrees. These are all examples of theta in second quadrant, in third quadrant. So first of all, let's visualize how this looks. So if we have now rotated our rod to a theta which is like this, I've rotated our rod to a theta which looks like this. This angle is theta. Now you might ask that, okay, why haven't I taken this angle as theta? Because I could also write this as 120. Because if this is 240, then this one is 120. But the thing is, the convention that we follow is that any angle like this, if we are writing this as plus of 240, for example, then this angle here will have to be written with a minus sign because it is clockwise. So this will be written as, let's say, theta prime, and that is equal to minus of 120. So the convention that we follow, the sign convention that we follow in rectangular coordinate system, which is this one. So the sign convention is that anti-clockwise angle is a positive quantity, whereas clockwise angle is a negative quantity. So that is why, since by default you can say we are assuming theta is a positive angle, so we have to show it in the anti-clockwise direction. That's why we have to show it. So now you can see that again, this being a standard unit kind of rod, if we drop the perpendicular here, your x projection is falling on the negative side again. So x is again negative. And if we drop the perpendicular on the y-axis, again it is falling on the y prime side. So even the y projection is negative. So what we understand about the third quadrant now in terms of formulae, first of all in terms of sign. So in the third quadrant, sine theta, which is equal to y, will be a negative quantity. Cos theta, which is equal to the x projection, will also be a negative quantity. And therefore, tan theta, correctly. So tan theta, which is y by x, that will this time become a positive. That is why you have that EST, because tan is positive. That's why EST. Now further, how we get the formula is like this. For the formula, what we'll do is so in this diagram, now what I'll do is I will take this angle here, this angle as alpha. Okay. So then I can say that okay, angle alpha is equal to theta minus 180 degrees. Okay. Because you can see that theta is equal to 180 plus alpha. You've gone beyond the 180 degree mark by an angle alpha, like that. And now if you look at just this triangle, so if I just draw this triangle separately now. Now forget about the quadrant fit. Just think of it like a triangle. So this is a triangle where this side is the hypotenuse is unity. This side as a side length is mod of x. This side as a side length is mod of y. And this angle here is alpha. So this triangle, this one here, just brought this triangle out. So for that triangle, what will happen? You can see that mod x upon L is equal to cos alpha. So mod x is equal to cos alpha. Because what is happening? L is a unit. Similarly, mod y upon L is equal to sine alpha. Mod y is becoming sine alpha. So now we've got the values of mod x and mod y. And going back to the earlier diagram, we understand here that x is negative, y is negative. Okay. So since x and y are both negative, therefore what is the value of x? It is minus of cos alpha. If I tell you that mod x is 5, but x is a negative quantity, that means what is x? It is minus 1, like that. So y similarly is negative, so it becomes minus of sine alpha, because x and y both are negative quantities. And by definition, what is x? It is nothing but cos. And what is y? It is nothing but sine. So now you can see you got the relation between theta and alpha. Okay, where alpha, you remember, was theta minus 180 degrees. That's what we written as alpha. So I'm just minimizing this a little bit now. So you come up to this last step, make sure you understand this up to where we got this. Yeah, Hitanshu, don't worry. You will get a video of this session. So in case you are having some connectivity issues or your audio got muted, unfortunately, whatever, you will get a full video recording of this lecture after this is over, and you will also get the notes that I'm making on the whiteboard. You will get a PDF version of it. But at the same time, you should also be jotting down the points yourself. Okay. The PDF notes are just to help you so that you have something very comprehensive and you can concentrate more on the lecture than making very fine notes yourself. But why you should keep noting things down is because as you note down, you understand better. Very good. So that becomes your final answer. That's it. So now let us convert this to the formula in terms of theta only. So the final part. So finally, this will become cos theta becomes minus of cos theta minus 1. That is the formula that we have for cos theta when theta is in the third quadrant. Similarly, sin theta becomes minus of sin theta minus 1. So you're replacing this alpha with what? Theta minus. And tan, you can just see from the ratio of these two, sine by cos is tan. So tan theta will become minus by minus, so the sign changes to plus. But tan of theta minus. So these are the formulae that I require for my quadrant. These are my quadrant 3 formulae. And that's all you need to know to apply. So for example, I want to calculate tan of 225 degrees. So from the formula above that, it just becomes positive of tan 225 degrees minus 180, which is positive of tan 45. That's plus 2. But for example, I want to calculate sine of 240 degrees. So that will become from the formula above the negative sign. So negative of sine 240 minus 180. That's minus sine. Minus of sine 60, which you know is root 3 by 2. If you use that value, it becomes negative of root 3. And like that, all other examples. So you can now make your own examples. Just take angles in the second quadrant, in the third quadrant, and then use these formulas. So this set becomes important. Okay, so later when you're revising the lecture, you can again go through the logic of this formula very carefully. But logic is for your understanding. The important thing is also that you should be equal to, you can also write 270 minus theta, but that will become, then sine will become cos and cos will become sine. Okay. So I want to keep things very simple here. So I'm expressing everything in terms of 180. You can also express second quadrant as 90 plus, and you can express third quadrant as 270 minus. Okay. So again, for your benefit, I will just take you through the diagram above also once, that you understand where these formulae finally come from. Yes, Ananya, you can tell me what is your doubt. Yeah, to again answer your question about 270 and 90, I can just say this much, that you learn that in maths, but it just becomes too many repeated formulae. Okay? When you already have a simple formula for third quadrant, I don't want to give you another formula which is confusing right now. That's the only reason. So I'm going to relate second quadrant as 180 minus instead of 90 plus. And I'm going to relate third quadrant angles as 180 plus something rather than 270 minus something. Alright, the drawback for me in doing too many angle type of relations is that I don't want so many confusing formulas. I want to keep things very simple. So that's one. And this in my mind is the simplest set of formulae. The ones I'm giving you over here, they are the simplest set of formulae, easiest to understand from diagram. That's one. But yeah, any standard trigonometry book you go through, there will be some alternate variations of this formula also. They will all give you the same value, but they are just variations of the formula. You can go through that, and that will be necessary in your maths also, trigonometry. But for your vectors, this is more than sufficient. That is the point. So now let us come to fourth quadrant. So theta in quadrant 4, which means that theta is greater than 270 degrees, but less than equal to 360 degrees. So here actually it becomes a little ridiculous. We express theta more in terms of negative angle. So if I say, for example, theta is 300 degrees, so it is better to express it as minus of 60. Or I say theta is 315 degrees. it's better to express it as minus, yes, minus 45, like that. Because as you can see that if I have something like this, where this angle theta is plus 315, for example, then it is easier to express it the other way. Just make sure that you understand that it's clockwise and not anti-clockwise. So it's following the fourth quadrant. So I can better express theta over here as minus 1. So saying theta is plus 315 is the same thing as saying it is minus 45. Just as saying it was plus 240 was the same thing as saying that it was minus 1. So here this typically becomes a little bit more preferable. So anyway, let's understand this geometrically now. So by now you got used to this, you see there's nothing very difficult. The moment you understand your angle is in the fourth quadrant, you will realize that the projection which is falling on the x-axis is falling on the positive side, whereas the projection which is falling on the y-axis is falling on the negative side. So if this is your theta, you can see that your x, which means cos theta, is positive, whereas y, which means sin theta, is negative, and therefore tan is also negative. But x is positive. So that immediately tells you that cos theta is a positive component. Whereas your y projection is falling on the negative y-axis side. So y is negative. That immediately tells you that sin theta is a negative quantity. And therefore tan will become positive. Tan theta will be negative. Cos theta is positive, and sin theta is negative. So that's it. Okay, now about the formula, it's very simple. If you take here this angle as beta or alpha or whatever, take this angle as alpha, and you look at this right angle triangle again. So for that right angle triangle, you can see that this angle is alpha. So alpha here is how much? It is 360 degrees minus theta. That's, and again in this triangle you can see that mod x by L is cos alpha. So cos alpha becomes mod x, and similarly mod y by L is sin alpha. So sin alpha is the value of mod y. And now you can see here that y is negative, x is positive. That means x is equal to positive of cos alpha, which means that cos theta is positive of cos alpha or positive of cos 360 minus theta. So this becomes the ultimate formula. Given some value of theta like 300 or 315 or something, you know this. Similarly, y, which is negative. So mod y was sin alpha. Mod y over here was sin alpha. So y will become minus of mod y. So it will become minus of sin. Remember, y is negative, whereas x was positive. That's why this positive and this negative sign. So that means my y, which is sin theta, is negative of sin alpha, which means that it is negative of sin 360 minus. And similarly, tan theta will just become ratio of these two things, so it will become minus tan alpha. It will become minus of tan 360 minus. So these become my formula for quadrant 4. These are the formula. So just take a full look at this and make sure you understand the final formula, how it has come. And then we'll do a couple of examples. Okay. So hope the formula are clear to all of you. Now let's just quickly work out some. So I'm now giving you some random examples. Okay, need not be only from quadrant 4. Just as an exercise, I'm telling you, work this out. So find out sine of 135 degrees, cos of 315 degrees, tan of 217 degrees, sine of 300 degrees. Correct. Prashant, your answer for the first one is correct. So Somaru, correct, good. So just work out these 4 examples all of you. Yes, Rimlim, correct. Tanish, correct. Good. Correct, Somaru. So first I will just give you the values in terms of the angles. Okay, then I will convert it into. So just as a hint, I will tell you that this is quadrant 2. This is quadrant 4. This is quadrant 3. And this is again quadrant 4. So using the formula for quadrant 2, we relate it with 180 minus theta. For quadrant 4, we relate it as 360 minus theta. For quadrant 3, we relate it as theta minus 180. Okay. And for quadrant 4, again 360 minus theta. So using these, okay. And of course, you have ASTC. So quadrant 2, so you know all this. Okay. So this will become positive of sine 45. So 180 minus this. This will become positive of cos 45 using that formula. And this will become positive of tan 37. And this will be negative of sine 30. So then you can see that this value is 1 by root 2. This value is also 1 by root 2. Both are positive. This value is plus 3 by 4. And this value is minus 1. So these are your answers. So tan 37 again is coming from sine by cos. Sine 37 was 3 by 5. Cos 37 was 4 by 5. So tan becomes sine by cos. Okay, so good. Most of you got these correct. Right, so this is about trigonometry in 4 quadrants. So now let's come to the analysis of our worksheet problems. Okay, so now let's turn to worksheet. So in some of the questions, I will give you some hints, and in some of them, I will give you the full method of solving. So I think question 1, 2, and 3 are pretty simple and self-explanatory. Should be clear. Okay. Now let's come to question 4. Okay, so question 4 is like this. You have to follow the instructions. Okay, that the person walks 2 kilometers towards north. Then turns and walks 1.5 kilometers towards east. Due east or due north means towards. So magnitude of the net displacement. So the net displacement is magnitude you want to find. So you can just convert this into a vector diagram. Yeah, Priyanshu, you want me to re-forward right now in the group? Okay, I'll do that. Okay, so people, I'm just re-forwarding the worksheet. It is already in the Orange House group, but many of you might have joined late or whatever. So just hang on. Okay, so I'm resending in the Orange House group the worksheet too. So if you have your WhatsApp open right now, you'll be able to access it. Right, so just go through question number 4 and you'll understand what the question is saying. So anyway, now we have to find the net displacement as a magnitude. So this is pretty easy. Okay. So what you do is you just draw a diagram and convert that information into this thing, into vector arrows. So if in your diagram this represents a north direction and this represents your east direction, west and south. So your first displacement, you can say, let's say that is S1. That is the displacement of 2 kilometers towards north. This is the S1, which should be 2 kilometers in length towards north. Now your S2 was a displacement of 1.5 kilometers towards east. So it's looking like this. So because one is towards north and the other is towards east, the angle between them is how much? 90 degrees. So the resultant displacement now will become like this. So here you don't even need to use the triangle law. You can just apply the this hypotenuse concept. So this is your net displacement. So S net, which is the vector sum of S1 plus S2, will have a magnitude of square root of 2 square plus 1.5 square. When you work out, will be 2.5 kilometers. That's your answer. You can also use the general formula here. The general formula is from triangle law, that the net displacement's magnitude will become the root of S1 square plus S2 square plus 2S1 S2 cos theta. But in this particular case, theta is how much? It's 90 degrees. You can see cos theta will become 0. So it basically comes down to this. So this is the full explanation of the fourth question. Pretty simple, I think. Nothing very difficult. Now, fifth question is about total distance. So total distance will actually be the distance he traveled from here to here, which is 2 kilometers, plus the distance from here to here, that is 1.5. So in fifth question, the total distance will just become the magnitude of the displacement in the first case plus this. So that you can see is 6.5. Oh, sorry, 3.5. Okay, next let's turn to question number 6. So question 6 is saying that I have two vectors whose magnitudes are 10 each and the angle between them is 60 degrees. So to find the net or the resultant. So let's say I'm giving the question like this, that a vector E has a magnitude of 10. A vector B also has a magnitude of 10. In whatever units. They might be displacements in kilometers, they might be force in newtons or whatever. And the angle between them is 60 degrees. This is the angle between E and B. So now we have to find the magnitude of the resultant. Where the resultant, as you know, is the sum of E and B. So you can just apply triangle law directly. You can directly substitute in the statement of triangle law without even drawing a diagram or anything. So you can just do this, that the magnitude of the resultant is given by the formula which we just written above. Root of A square plus B square plus 2AB cos theta. When you substitute that over here, this is 10 square plus 2 into 10 into 10 into cos of 60, which you know is half. So further, it becomes the root of 100 plus 100 plus 100. So that becomes 10 or approximately 17 point. That becomes my magnitude of the resultant. Whatever unit the individual values of S1 and of A and B were, that will become the unit of the final dimension. So nothing at all in this, direct substitution. Cos 60 is half, right? Substitute cos 60 as half. So the third term will become 100. Substitute this. So for this chapter, you have to know the standard values: 60, 45, 30, 37, 53. Those standard values which I have written above in the top. Yes, Iitanshu, I'll come to the question. Don't worry, come to just have to be a little patient. Okay, now there is interestingly one more way in which we can solve the problem, which is not necessary here because the formula is fitting nicely, but we can also solve geometrically. So alternatively, we can also solve this geometrically. where the solution becomes something like this, that suppose this is the vector A and its magnitude is 10, then comparatively the vector B will have to be along this kind of line. Have to be along something like this. Because it is given to us that B's magnitude is 10, but the angle that the direction of B is making with respect to A, this angle is 60 degrees. So now if I geometrically want to find out A plus B, I'll have to draw these two vectors back to back, head to tail kind of thing. So draw the vector A, and then from the tip of A's head, draw the vector B. So this is A, this is B, and this is the angle between them, which is 60 degrees. And their magnitudes are 10 and 10 each. So in this diagram now, the resultant of the two will be this vector. As per the geometrical construction, okay, so to answer your question, Beta, you have to go through worksheet. You have to go through session 2 very carefully to understand why I am using triangle. Right, so I want to find out this side now, how much this is. So what I notice here is that this is an isosceles triangle. Okay, so it is because this side is equal to this side. That means whatever this angle is, say alpha, this angle is also the same. So isosceles triangle, that's the first thing I use. Okay. Then I use the fact that the sum of interior angles is equal to the opposite exterior angle. So alpha plus alpha is equal to theta. So that means alpha is equal to 60 by 2 or 30 degrees. So that is the second thing I use as a trick. And the third thing I use as a trick is in an isosceles triangle, if I drop a perpendicular like this, okay, then that perpendicular ends up bisecting this side. So this will be r by 2. And this is r by 2. So now I can use trigonometry. You can use cosine rule. Cosine rule is the same thing as the vector. In fact, the derivation of cosine rule in a way comes from vectors. So for example, in this triangle now you can see that cos alpha is base upon hypotenuse, which is the magnitude of it. So further, cos 30 degrees will become r by 2 divided by a equals 10. So as you can see, root 3 by 2 will become r by 20. So what is the magnitude of the resultant? Is 10. This is that magnitude of the resultant, which is magnitude of A plus B. So this is a, you can say, like a nice creative way of solving the problem, making use of something more fundamental, which is geometry of isosceles triangle, rather than brute force method where I just substitute everything in the formula and just let the formula do the computation for me. Of course, you have to understand. Wait a minute, just a second. I'll label the angle. This angle, this was our theta. So first of all, understand how we have constructed this triangle, this vector triangle from this. Given these two vectors, this was what was given in the question. This was given. And what we wanted to find out is the magnitude of E plus. So to find that out, we constructed this triangle. Okay, and now you can see with this we answered question number 7 also. That what is the angle that the resultant makes, that is 30 degrees, that we got from this. This angle alpha is 30 degrees. We've already got that also. That alpha is 30 degrees. So this little calculation here is also solving us for us question 7. This is what question 7 was. Okay, the angle alpha, that is the angle that the resultant makes with respect to the vector A. So that we got already. We got it as 30 degrees. Okay. That's the geometrical method. Okay. But I'll also show you the formula based method for angle. So the formula based method for question 7. Same data as question 6. And theta is equal to 60 degrees. Now we want to find alpha, that is the angle of the resultant with respect to the vector. Whereas this was angle of vector B with respect to vector B. So for that we had the formula tan alpha is equal to B sine theta upon A plus B cos theta. So we can use the formula based method also. We just substitute, so 10 sine 60 divided by 10 plus 10 cos 60. So 10 into root 3 by 2. Actually just cancel off the 10, that will be easier. 10 plus 10 into half. So this is root 3 by 2 divided by 1 plus half after cancelling of the 10. So that's root 3 by 2 divided by 3 by 2. That's root 3 by 3, which is 1 by root 3. So tan alpha is 1 by root 3. So that means alpha is 30 degrees. The same thing that we saw geometrically above, now we are just showing that by formula. So you could have solved question 7 by either of the methods. Okay, so that is this question. Now next I am coming to question 8. Question 8. So 8 में क्या करना है? Again, it is given to you that magnitude of A is equal to magnitude of B. This is given. This fact is given. And the angle between them is 120 degrees. This is what is given. And then we have to find mod of A plus B. So let's say you want to find this ratio. So you can answer all the questions. So what we do here is just take mod A equal to mod B equal to some unknown quantity, let's say small a or x or whatever, and theta equal to 120 degrees, and substitute this in the formula. That mod of A plus B is equal to root of A square plus B square plus 2AB cos theta. So just do this substitution, and from that you will get cos theta, and from that you will get, from that you will, it's the other way around, from that you will get mod A plus B. You will get mod A plus B in terms of x. So you will get this thing in terms of A or X, whatever you take in the magnitude. So from that you will know this ratio. Okay. But just be mindful of one thing here, that when you substitute, cos 120 will be minus cos 60. So it will be minus 1. Just be mindful of this factor. Or alternatively, what you can do is, so this is one method. Method 2 you can use is geometrical. Draw the triangle. Draw the vector triangle, and that will also give you an interesting solution. So this is how you can work out question 9 yourself, or rather question 8 yourself. Okay. So try it out, you will get the answer pretty easy. It should not be difficult. Okay, let's discuss about question 9 next. Now, question 9 is a slightly different type of question. It is asking about inequality. So, we have to understand this carefully. So, it is given that the angle theta is 45 degrees between vectors A and B. So, then it is saying that can we compare the quantity mod of A plus B and the quantity mod A plus mod B. Okay, so, which of these is larger? Compare that. So, for that, that's basically what we have to do. So, let us say mod of A is capital A, mod of B is capital B. So, mod of A plus B becoming how much? Root of A square plus B square plus 2AB cos theta, where theta, remember, is 45 degrees. What is given in the question. So that is root of A square plus B square plus root 2 times AB. Yes, out there. When you put cos theta equal to 1 by root 2, you will get this. So this is your mod of A plus B. Whereas, what is mod A plus mod B? That is just A plus B. So that you can write as square root of A plus B whole square. Because this is in square root form, so that will be easy to compare. So it is square root of A square plus B square plus 2AB. Okay. That is your mod A plus mod B. Expressed in square root form, it is like this. So let's say this mod A plus mod B is the quantity Y, and this was a quantity X. So now you can compare X and Y. So X you can see is root of A square plus B square, and to make it further easier, just think of root 2 as 1.4 approximately, and Y was root of A square plus B square plus 2AB. Immediately you can see that Y is greater than X. That's it. Okay. And definitely this is greater than A, because so obviously you can see that X is greater than A. There's no doubt about that. But you can also see that X is less than Y. So that is how it works. Okay, so this is a little bit about mathematical manipulation, understanding this. Okay, no problem. You will get the recording, so don't worry. Okay. All right. Now next, let's come to question 10. So in question 10, it says that E plus B, this vector, let's say that we're denoting is R. Now what it says about this resultant, it is perpendicular to vector E, okay, and the magnitude of the resultant, that is mod R, is twice of the magnitude of E. So from this you have to find the ratio of mod A. Okay. So I would say, if you haven't done this question, try this geometrically. Try by geometry. That is the triangle, draw the triangle. And you'll understand very easily how to do this. I'm coming to the solution in a moment, but just draw the triangle. You'll see it's very easy. Draw the vector triangle with these two conditions. Okay, that this condition is there and this condition is there. So when you draw the vector triangle, you'll realize that if this is your vector E, then your vector R, which is the resultant of A, that one is like this one. It's double in size. So this is the resultant. Is E plus B. It is both perpendicular to A and it has a magnitude which is twice of B. Right? This is the vector A, magnitude. So then where is the vector B lying? Because this is the sum of A and B. So the vector B must be lying here. That's the only way sum can be. So this is where the vector B is lying. So its magnitude we don't know. And we don't know this angle also. We want to find out B's magnitude and we want to find out the angle. We can do it like this, that we can see it's a right angle triangle. So B square is equal to A square plus R square. That is E square plus 2A comma square. That is 5. That means that is what the question is given here. So B's magnitude is root 5. That's 150. Yes, Kushal, that is essential because that's the process of addition. Remember the method of doing vector addition by, yeah, exactly, Pythagoras theorem we use. The method of vector addition is just that. The statement of that method is this: that draw the first vector, and from the head of the first vector, draw the second vector, and the resultant is the third side of the triangle. So when we are applying the triangle law, we have to follow the principle of the triangle in terms of how we draw the vector. Now question 11 is kind of easy. Do by use similar method as you've done another question where we are comparing two things. Just a minute, I'll take which one I'm saying. As question 9. Try it out yourself using the similar kind of method or logic as we've done in question 9. You can still discuss with me later if you've not understood how to solve the question. But I would like you to try this yourself. Now let's come to question 12. So 12 says that E and B are perpendicular to each other and C is minus of 2B. And which of the following is correct? It is very simple. Just draw the two vectors. Suppose A is like this and B is like this. What else is said about this? So you don't know about the magnitudes, but we know that they are perpendicular to each other. That is given that C is equal to minus of, what is it, twice of B. Yes, it is minus 2B. So according to this statement now, how will the vector C be looking in the diagram? The vector C will be like this. It will be opposite to B but twice in B. So C will be now a vector like this. It will be opposite to B in direction because it is negative. No? When we multiply with the negative quantity, so it's along this line, but the magnitude of C will become twice of B. Because the meaning of this only is that C is opposite to B in direction, and mod C is 2 times mod. Because mod doesn't come with sign, the mod removes the sign. So the magnitude of C is twice the magnitude. So now from this you can answer all the logical things which are asked. Now question 13. First of all, question 13, there is a misprint in the question. 13. Make option C should be 90 degrees instead of 37. Should be 90 instead of 30. Now let's understand. So the question is saying that F1 is a force of magnitude 100 newtons. F2 is a force of magnitude 80 newtons. And F3 is a force of magnitude 60 newtons. Such that when you sum them up, if all three are simultaneously acting, that means their resultant sum, then the net force is 0. That means the resultant sum should be a null vector. So from this we have to find the angle theta between F2 and F. So this is again slightly different type of question. I'll discuss how to solve this. So let's understand what this statement now means. That F2 plus F3 plus F1 is. So now see, given that F1 plus F2 plus F3 is equal to a null vector. We can say that the vector F1 is negative of the sum of the vectors F2 plus F3. So this statement is the same as this statement. I'm just taking F2 and F3 to the other side. Now next what I'll do is I'll take mod on both sides. So magnitude of left hand side should be equal to magnitude of right hand side, which is minus of F2 plus F3. Now we understand that since we are taking magnitude, the minus sign is of no consequence. That means the magnitude of F1 should be equal to the magnitude of F2 plus F3. Now see what was given to us. Given was in the question, the magnitude of F1 was 100, the magnitude of F2 was 80, and the magnitude of F3 was 60. So suppose the angle is theta for F2 and F3. The angle between F2 and F3 is theta. Then the left hand side directly substitute as 100, but the right hand side will become what? Square root of F2 square plus F3 square plus 2 times F2 into F3 into cos theta, where theta is unknown. So you can see that 100 is equal to square root of 10 raised power 4 here plus something 2 into 80 into 60 into cos theta. So to square both the sides, you can see that 10 raised power 4 is equal to 10 raised power 4 plus this whole quantity 2 into 80 into 60 into cos theta. So that means this quantity must be 0. That is only possible if cos theta is 0. That means theta is 90 degrees. In fact, the correct answer will be 90 degrees. There was a misprint in the question option which I told you. So option C will be the correct answer, but it should be changed to 90 degrees. So this is question 13. Just make sure you understood the steps in this. Okay, people, so hope this is clear. Now moving on to the 14th and 15th question, the last two. Okay, so let's go through the 14 question language, or more importantly, the diagram. What it's trying to say, two horizontal forces, one whose magnitude is given as 10, the other whose magnitude is unknown, but is at an angle like this. It's acting 30 degrees north of east. Sorry, 30 degrees east of north. Resultant of these two is along the north direction. So you can interpret the language of the 14th question like this, that you have, let's say, one force, which is like this, which I have not given as a symbol, but now let me add that as a symbol also. So this is a force Q, let us say. It is 10 newtons towards west. That is given to me. And then there is one more force, which is like this. This is your north direction and this is your east direction. It is at 30 degrees to the east of north. So that force is like this. So this angle should be 30. It is given clearly that it is 30 degrees towards east of north. So from north you have to turn towards east by 30 degrees. That's a force P, and its magnitude P is not known. Okay. Now the resultant of P and Q, these two forces, that resultant is towards north. So from that you have to find the magnitude of P. Yeah, if we go by algebraic sign, you can say it is this thing, but that is, we say plus minus only when we will label an angle as positive or negative, only when we're talking in terms of a XYZ coordinate system. Now, here we're just saying arbitrarily, we've already given the direction, it's towards east of north. So we don't need to say plus minus to explain whether it is clockwise or anti-clockwise. Just giving the magnitude of the angle as 30 degrees, and we are giving its sense, it's east of north. So it's like this, okay. We might have, somebody else might have labeled north like this and east like this. तो उसके केस में वो एंगल कैसा हो जाएगा? That direction will be like this, 30 degrees like this. So it's just a matter of how we have labeled our diagram. But the important thing is this now. So let us do the vector sum concept over here. So let's draw the vector triangle for the resultant being the vector sum of P and Q. So for that, what we'll do is we'll first draw the vector P, which is like this. This is of some unknown magnitude. But we know that this angle is 60, or this angle is 30. We know that. Now, on that, let us draw the vector Q. That vector is something like this. And we know that one's direction is like this, towards west. But we also know its magnitude is 10. Now, in this diagram, what is the resultant of these two vectors? That is this one. That is this one. Now, the resultant should actually be towards north. So, the resultant is exactly towards north. We know that actually what should happen? This vector, its head should end over here. So, in the perfect diagram, it should be like this. This vector's head. So, this is the resultant, whose magnitude we again don't know, but we know its direction is towards north. That is given to us. So again, we can make use of, so now we know that this angle is 90. So we can make use of Pythagoras theorem. Oh, sorry, we can make use of trigonometry. So we can see that in this, 10 by P will become nothing but perpendicular upon hypotenuse for this angle. So it is sine perpendicular upon hypotenuse. So it is sine. Okay. So P should become 20. And R similarly will become 10 root 3. So this is the way of solving the question. Because here, everything is given in terms of geographical direction with angle and all. You have to interpret it by making a diagram. You cannot get away with just, using some kind of formula. Yes. So just a moment. All right, so that's that. Now about the last question, question 15. So it is given to you that you have two vectors such that their magnitudes are in the ratio 1:2, and the resultant makes an angle of tan inverse. This symbol is called tan inverse √3/2 with P. So we have to find whatever the angle between them and all that. Okay, so let's understand first of all what this means. It means that if some angle is given as tan inverse of √3/2, that means that angle itself is such that tan of it is √3/2. This is the meaning of it. As a different example, suppose I give you that theta is tan inverse of 1. So you know that tan theta should be 1. So that means that theta should be 45 degrees. Or if I give you, for example, that theta is sine inverse of √3/2. That means sine theta is √3/2. That means theta is 60 degrees. That's the kind of logic. So if some angle is given as tan to the power -1, which is read as tan inverse. Okay, so this is read as tan inverse of √3/2. So that implies this thing. This implies if alpha is given tan inverse of this one, it implies that tan of alpha is √3/2. Okay, so that's the meaning of this. Okay, so now we have to just use the formula. So we have to just understand here that suppose P is, what is it, 2:1 or 1:2? So if suppose P is x in magnitude, then Q is equal to 2x. Okay. So then think of the vector triangle. Some P and Q are like this, but Q is longer in length. So this is some vector Q, this is some vector P. This is of x length, this is of 2x length, and there is some arbitrary angle theta between them. Now their resultant is such that it's making an angle alpha here. This is the resultant. This is P plus Q. So that angle alpha is given such that tan alpha is √3/2. This is given to me. So from that I have to find out theta. So let's use the formula that tan alpha will become P sine theta upon, sorry, Q sine theta, my mistake. The B sine theta for A plus B. So Q sine theta upon P plus Q cos theta. Now tan alpha is √3/2. So substitute that here. So that becomes, on the other side, your x will cancel out when you substitute. So 2x sine theta upon x plus 2x cos theta. So this becomes my equation. Okay. So this equation now implies that √3/2 is equal to 2 sine theta upon 1 plus 2 cos theta. So now the whole question becomes, how do I solve this? So for solving this, use the identity that cos square theta can be written as 1 minus sine square theta, or sine square theta, whatever. Sine square theta can be written as 1 minus cos square theta. So use that. So now square both the sides. So squaring both the sides, same thing here, whole squared. So next step, it becomes 3 by 4 is equal to 4 sine square theta upon 1 plus 2 cos theta, a whole square. And then use this identity. Okay. So 3 by 4 is equal to 4 times 1 minus cos square theta upon 1 plus 2 cos theta ka whole square. Then solve for cos theta. It's a quadratic equation in cos theta. So solve for it. So just to make things simple, let us take cos theta as some new variable like z or something. Okay, so this becomes 3 by 4 is equal to 4 into 1 minus z square upon 1 plus 2z the whole square. So solve this as a quadratic equation for z. So 3 times 1 plus 2z whole square is 16 times 1 minus z square. So here you can see that this will be 4 into 3, 12 z square plus 4 into 3 again, so 12z plus 3 is equal to 16 minus 16z square. We get some kind of relation. So 16 plus 12 is 28 z square plus 12z minus 13 is equal to 0. Okay, so you might have to check my calculation if it is correct up to this point or not, because I'm just doing this arbitrarily. Okay, but this is the method of solving. So now solve for z from this, and from that you will get cos theta. So from that you will get theta. So continue this, solve for z, then that z is equal to cos theta. So from that you will get theta. So this is a bit of a lengthy calculation. So just try this out yourself after you come up to this step. And if you have difficulty with the final working also, you can discuss with me later. Okay. But the important thing was this, the approach to the question. So make sure that you understand this part first. Okay. The rest of it is solving. Make sure that you understand up to here first. Yeah, that's what I'm explaining again, right? The 15th sum I'm explaining again. So this part was the information that was given in the question. Now from this we are understanding that if it is given to me that the angle that R makes with respect to P is tan inverse root 3 by 2. So if that angle is alpha, alpha is equal to tan inverse root 3 by 2 means that tan alpha is equal to root 3 by 2. So this is the first thing to understand. Okay. And P and Q's ratio is 1:2. That means if I take P as X, Q's value is 2X. So this is how your vector triangle is looking, where this angle alpha is such that tan alpha is this. Now that tan alpha is equal to how much? It's root 3 by 2. And P and Q are how much? P is X and Q is 2X. So making use of that. Yeah, so Z's value you're getting how much again? half, no? Yeah, you will get two values, but the one negative and one positive. So eliminate the negative root. So take the positive root, which is half. So z is half, means that cos theta is half. So that further means theta is how much? 6. So anyway, don't worry about the working, that you will come to. And now you guys have verified that my working is correct up to this time. But first, importantly, understand how I converted the information of the question into this over here. This thing. Alright, so hope this is clear, people. As I said, you will get the PDF of this, so you can refer to that. But try to solve it from this point yourself, using this trick that I've told you. That when you have an equation of this type, the equation has both sine theta and cos theta. You always have to use this identity that sine square theta plus cos square theta is 1. Otherwise, it looks like you have two variables in the equation, sine theta and cos theta. But actually, you have only a single variable because sine theta can be written in terms of cos theta. So here the vector triangle is just the standard vector triangle. I've just assumed that I have two vectors of magnitude x and 2x and some angle theta between them. And parallelogram method bit I'll be teaching later. So, some of you asking me about doubt of parallelogram law. So that I will be teaching later. There's not too much difference. The formula is the same for parallelogram and this. And 14th question also see I made a vector triangle only. Vector P is like this, vector Q is like this. So the sum of P and Q will be P drawn, then Q drawn. So P plus Q becomes the third side of the triangle. So if you have, for example, a vector like this and a vector like this, and you want to find their sum, then how we find the sum of these two vectors, E and B? Same way I have found the sum of P and Q, but only in this one of the vectors is this one, and the other vector is this one. So the resultant is given in this one. So do a revision of the video session later with the whichever problem you are still having some difficulty in. Then try it out yourself. If you don't get it, then you can discuss with me over WhatsApp also. Okay? So now let us come to the final part of the lecture, just a few minutes. So we will understand component representation of vectors. So in component representation, it is more or less a representation using a sort of coordinate geometry method. So it is basically a method of representation using a Cartesian coordinate frame. Okay, or axis, using coordinate axis. Okay. So first we will do this in 2 dimensions. Later we will come to 3-dimensional method also. So in 2 dimensions we have only 2 axes, x and y. By default we call them x and y, which are mutually perpendicular, and typically we draw them like this. Though there is actually no restriction that you have to take the y-axis upwards and the x-axis horizontal. You can take them any way you like, okay, but it is mandatory that they should be perpendicular to each other. Okay, so these are my what we call Cartesian axes, x and y. They have to be perpendicular. That is compulsory. Okay. Now the first thing we do after this is we define something called the standard or base unit vectors. So the next definition for us here is what we call the base unit vectors. We already understood before that a unit vector is a vector of magnitude 1. Okay. So we define I cap. The symbol I cap is used for a unit vector along the positive x axis, okay, or a vector of magnitude 1, okay, along the positive x direction. So for example, in the diagram here, I cap will look like a vector like this. It's a vector which is pointing along the positive x direction, but its magnitude is unit. And similarly, we define another unit vector. So the base unit vectors are I cap, and the second one is given the name j cap. Okay. So it is, this one is a unit vector along the positive y axis. So in this diagram, this unit vector will look like this. It's pointing along the positive y direction. So it will look like this, and its magnitude is unit. So that's the first thing. We define first, in order to represent anything in the component form, we have to define some coordinate frame. So some point has to be defined as origin, some particular direction has to be defined as x-axis, and something perpendicular to that has to be defined as y-axis. Now once we've defined that, the next definition we'll have is the two standard unit vectors, or the two base unit vectors. Base unit vectors, or we can also call them standard unit vectors. And they are given the special name I cap and j cap. And they look like this. Okay. So once you've done that, so for example, any vector along the x-axis or y-axis or negative x-axis or negative y-axis, we can very easily define. So for example, now, if I have a vector E, which is 5 I cap, and a vector B, which is, let us say, minus 3 j cap. How does that look like now? So it's very easy to understand. It is just coming from that operation that we learned. Multiply a scalar with a vector. So here I cap is defined as a unit vector along the positive x direction. So 5 I cap is nothing but 5 times I cap. So it will become a vector of magnitude 5, and because 5 is a positive quantity, what about its direction? It will be along the positive x direction. So in this diagram now, the vector E will actually just look like this. It will be a vector pointing in this direction, but its magnitude will become 5, okay, because it is 5 I cap. But similarly, in the same diagram, what about the vector B? The vector B will be pointing along the negative y direction, because what is happening? Its j cap is multiplied with a minus sign. So it will be pointing downwards like this. Again, where we draw it from is not important. We could have drawn it here, we could have drawn it here, but its direction is downwards. So this is the vector B, and its magnitude is 3. So this is the interpretation of this. So this is how, for example, we can represent the most simple vectors which are lying along positive x direction or negative x direction, positive y direction or negative y direction. We can just represent them by one of the two unit vectors. Okay, that's the first thing. Now next we'll see how we can use the same system to define any arbitrary vector which is at some general kind of angle. It need not be along the x-axis, need not be along the y-axis. How will we define a vector like that? So let's understand that next. Okay. So I think this part is clear. This is very simple. Okay. So now let us look at an example of a vector which is, let's say, like this. The vector E is now, let's say, 3 I cap plus 4 j cap. So how will this look like? Okay, so let's understand this. So just understand the E vector here as the sum of two other vectors. 3 I cap on its own is a vector we have seen just now, and 4 j cap is also a vector on its own. So this vector, just 3 I cap alone, is a vector that looks like this. It's a vector that is pointing in this direction and has a magnitude of 3. So this is my vector 3 I cap. It's pointing like this and its magnitude is 3 units. Now to that I'm adding what? So this is basically a vector 3 I cap which is added with, it is the resultant of 3 I cap and 4 j cap. It's like this. So E is, you can say, the resultant sum of the vector 3 I cap and the vector 4j cap. So now to this I have to add a vector which is pointing along this direction. And it is like this. This is my vector 4j cap. So now what is the vector A? It is the sum of these two. So in this diagram, where will the vector A be lying? The vector A will be lying like this. So this will be the vector A. And obviously in this triangle, this angle will be 90. And suppose this angle is theta. So you can see that such that the magnitude of the vector A from the diagram you can see is becoming the hypotenuse of 3 and 4. That is nothing but 5. And the angle theta is such that tan theta is 4 by 3. Or you can say that sine theta is 4 by 5 or whatever. So all of these will tell you the same information, that theta is 53 degrees. Okay. So that is how we interpret a vector now, by constructing it using the sum of two vectors, one along the x-axis, one along the y-axis. Now one of these numbers could have been negative also, so then that would have been like that, or that would have been like this. Okay. So the vectors can lie in all four quadrants according to the quantity we are multiplying with I cap and j cap being positive or negative. Okay. So just understand this example, and then we will come to the general definition of vector in component form, and we'll see something very easy as long as we are clear with the concept of projection in trigonometry that we've discussed earlier. So as long as we are clear with that, you'll see this is very easy to understand. So just note this down, people. Then so from this, let us now construct the general formula for vector in component form. Or in component notation, as we like to call it. So let us see the general formula. So now supposing with respect to my standard XY coordinate frame, just drawing the like this. So this is my vector A, and this angle is theta. Now if I think in terms of components, okay, we realize that the components are nothing but projections. Just like we had seen projections in the case of the trigonometry definition. So if I define this as some scalar quantity Ax, some value Ax into I cap, and then if I define this vector here as some scalar quantity Ay into j cap. What in the previous question I had taken as 3 I cap plus 4 j cap. Now they are just some general arbitrary values. Then I can see in the diagram the vector E is nothing but Ax I cap plus Ey j cap, where the name that we give to Ax is that it is the x component of the vector A. And the name that we give to Ay is that it is the y component of vector A. Now these are definitions again. these two are basically definitions. These are definition of components. Okay. Components can also be thought of as projections. Components can also be called projections. It is a projection of vector E along the x-axis and the projection of vector B along the y-axis. It can also be called projections. Okay. So first of all, make sure you understand this. Okay. The earlier example I took, it was just a special case where AX was 3 and AY was 4. But in general, we represent a vector as some quantity into I cap plus some quantity into j cap. So those quantities, if we give them the general name AX and AY, they are called the X component and Y component respectively. Okay, so just make a note of this, people. We just finished in another 3 to 4 minutes. Okay, people, so hope this is clear. Now, again, in the diagram, you can see that once you have defined the vector like this, there is a special relationship between these quantities. You can see that the magnitude of the vector E is basically this hypotenuse. So, what relationship it has with AX and EY? It is square root of AX square plus EY square. And the angle theta is such that this is a right angle triangle. So, tan theta is equal to EY by AX. Okay. Or consequently, in the same thing now you can see that if you think of this right angle triangle in terms of the hypotenuse E and the angle theta, you can see AX is nothing but E cos theta. Because cos theta is defined as base upon hypotenuse. And similarly, EY is nothing but E sin theta. So this is the formula set that we can use if we want to convert magnitude and angle into components. Or this is the formula that we can use if we want to convert components into magnitude and angle. Okay, so the application of this whole concept, this diagram, becomes this formula set or this formula set. So I know some of you have a mentoring session at 2:30, even me, but just another couple of minutes I'll finish. So it's a very simple example. Suppose I have this, that I'm just giving you a couple of vectors. Okay. And asking you to now express them in component form. Like let's have a vector like this, and I have another vector like this. Let us say this is vector A. Its magnitude is 50, and this angle here is 53 degrees. And the other one is vector B, and let's say its magnitude is 20, and this angle here is 60 degrees. Okay. And these are our standard x and y axis. So this is the negative x-axis. This point is the origin model. So now you say express vectors E and B in component form. Okay. Or sometimes you also call that in I cap j cap form. So it will be in terms of I cap and j cap. So I cap j cap form or I cap j cap notation. Express that. Okay, so it's just formula based, as you can see. So you can see that for vector A, the magnitude of A is 50 given to me, and the angle that A is making with the x-axis is 53 degrees. So it's given to me. So what will be my x component? It will be A cos theta. So that is 50 cos 53. If you go back to your table earlier, which I had given you, cos 53 is in fact 3 by 5. So this becomes 30. Whereas your AY, which is A sin theta, will become 50 into sin 53. So that is 50 into 4 by 5. And that is nothing but 40. So the vector A now, when we express in component form, this is AX and this is AY. So the vector A in component form is becoming 30 I cap plus 40 J cap. Very simple. Now use the same to find out how we'll express the vector B. नहीं बेटा work is equal to force and displacement का जो relation है, that is actually something called dot product or scalar product, which will be coming to much later. In the 4th or 5th lecture, we will be coming to that. Okay. So still some time before we understand. Alright, so let us look at what's happening for vector B over here. Now vector B, we have to be a little careful when we are expressing the angle. Okay, because remember the angle is with respect to the standard x and y axis. So it's not 60 degrees. And the angle theta is with respect to the positive x axis. So it should be written as 120. So for the vector B, the proper way of expressing it will be that while the magnitude of B is 20, but this angle, this is your theta for B. Whereas this angle was given to me as 60 degrees. You can see that for B, the magnitude of the vector is 20, but the angle it is making with the x-axis is 120 degrees. So the x component will become negative because cos 120 is negative, which makes sense because you can see that this is along the negative x-axis. So dx will be d cos theta. So that is 20 cos 120 degrees. So again we'll use the second quadrant formula. So that is minus cos 60 or minus half. So minus 10. Okay. So the x component of b is becoming negative. Correct. So Molu, that's correct. Okay. And similarly, y component is d sine theta. So 20 sine 120. So that is 20 into positive of sine 60. So this is in fact why our trigonometry in 4 quadrants is important. So you can see that becomes 10 root 3. So this is my b1. So that is why the vector b will be minus 10 I cap plus 10 root 3. Yeah, you can take 10 common, that's not a problem. So you can also write the vector b here. So it can also be expressed like this, that b is 10 into minus I cap plus root 3 j cap. That's another way of expressing the same thing. So no problem there. Now, just as a last thing, conversely, if we have something like this, as an example, suppose vector E is given in component form. Suppose this is given as 12 I cap minus 16 j cap. So find the magnitude of the vector E and the angle theta with respect to the x-axis. What is the angle it's making with respect to the x-axis? So here, just drawing the vector makes sense. Okay, so what we can do is we can just construct the vector with respect to a standard x and y coordinate frame. You can see that in that diagram, the vector is looking like its components are what? The components of the vector is plus 12 along the x-axis. So plus 12 I cap will look like this. And minus 16 j cap will look like it's here. So you can see it's in the 4th quadrant. The vector actually along the 4th quadrant. So this is minus 16 j cap. This is plus 12 I cap. So the vector is actually the sum of plus 12 and minus 16. Okay. So that vector will have a magnitude of how much? The hypotenuse, which is 20, but its angle will be in the 4th quadrant. So that we can write as minus of something also, or we can write it as in terms of something greater than 270 also. Okay, so people, unfortunately, my whiteboard has got hung up and we are just running out of time. So I'll just tell you the answer in this case. Okay, you can work it out yourself. I will send you the notes which has the solution of this. So the answer to this last example will become that magnitude of A is equal to 20 units. Okay, just write it down. The magnitude of the vector A will be 20 units. Whereas the angle it will make with the x-axis, that theta, that theta will actually be minus 53 degrees. Okay, it will be minus 53 degrees, or you can write it as 307 degrees. So just write down the answer. Mod A will be equal to 20 and theta will be 307 degrees or minus 53, whichever way you want to express it, because it's in the fourth quadrant. Okay? So I will send you the PDF complete with the working of the last part. Unfortunately, my computer has just got hanged and I'm out of time for rebooting and all that. But anyway, that's it for today's lecture. So make sure you understand the concept, the last concept that we've discussed, that is the component representation of a vector. That is both the things, that if the vector's angle and magnitude is given, then how to find AX and AY, or consequently, like the last question, if AX and AY are given, then how to find the magnitude of the vector and the angle it is making with the x-axis. Okay? So that's it for today's lecture, people. I will give you a worksheet 3 also eventually, but first complete worksheet 2 fully. And after completing worksheet 2, any doubts, etc. remaining, make sure you discuss with me. You can send me individual WhatsApp messages right through the week till we come to next week's lecture. And that's how you can complete worksheet 2. So that's it for today, people. All the best. Okay.